Hey everybody, it's Miss Williams, and this is Quadratics Unit, Day 2. So again, don't write these down, these are just fun facts. Did you know that baseball and cricket are the only major sports where the defense has the ball? Think about that. Did you know that the Pentagon has no marble in it because it was built during the World War II, and Italy, the source of marble, was an enemy country? And finally, did you know that more candy is sold on October 28th than any other day of the year? Thanks to Halloween. It'll be Halloween before you know it. Alright, so we have two I can statements today. The first is use the square root method to solve quadratic equations, and the second is use the properties of I to evaluate an expression. Alright, so first I can statement. Solving quadratics using the square root method. So again, you don't have to write every single thing down. Remember, it's notes for you. Okay? So now that you know that when looking at a graph you can solve a quadratic by where it crosses the x-axis, now let's solve a quadratic using the square root method. So we're going to use algebra this time to solve a quadratic. So can you solve for x? X squared is equal to 9. Well, probably in your head you know that 3 times 3 is 9, right? But mathematically, what are you doing? Well, to get x by itself you must square root both sides. But you have to remember that the square root of 9 is equal to both 3 and negative 3. Because if you think about it, 3 times 3 is 9, and also negative 3 times negative 3 is also 9. So you're actually going to get two answers. So whenever you take the square root of both sides, and I would write this part down with the asterisks, you must remember the plus and minus sign, positive and negative of the answer. Okay, that's important. Write that part down. Alright, so let's get a little harder. Can you solve for x on this problem? X squared plus 4 is equal to 20. So definitely write these examples down on your notes. So the first thing I would do is have to get the square root by itself first before I can square root both sides. So I need to get rid of that 4 by doing subtract 4 on both sides. So that's going to leave me with x squared equals 16. Now once the x squared is by itself, I can do square root. So I'm going to square root both sides, and I have to remember that positive and negative stuff. So when I square root, that goes away. And when I square 16, I get both positive and negative 4. And you can write it condensed like this, with a plus and then a minus sign right underneath it. And that lets everybody know it's positive and negative 4 is your answer. It gives you two answers. Alright, let's try just a little bit harder one. This says x plus 3 all squared minus 2 equals 23. So I'm going to get the squared part by itself first. I'm going to add 2 to both sides. Alright. That ends up giving me x plus 3 squared is equal to 25. Now I'm going to square root both sides again. Alright, when you square root it goes away, and the square root of 25 is 5, both positive and negative. So I end up with two equations that I've worked here. Okay, so I have x plus 3 is equal to 5, and I have x plus 3 is equal to negative 5. Now I wrote these separately because I have to do more stuff to get my final answer. Because my final step is going to be to solve for x as needed. So I'm going to subtract 3 from both sides in the first equation and subtract 3 from both sides in the second equation. So 5 minus 3 gives me 2, and negative 5 minus 3 gives me negative 8. So what would happen about this problem? So x squared plus 14 equals 10. So same process, subtract 14 from both sides, and I get x squared is equal to negative 4, and then I square root both sides, and here's my problem. Okay, we have a problem now, and that is you can never take the square root of a negative number because you can't go negative 2 times negative 2 doesn't give me a negative 4, it gives me a positive 4. So there's not ever a number that can multiply by itself to get you, you can't ever multiply a number by itself and get a negative number. Alright, you can never take the square root of a negative number. So this was an issue many years ago. So there was a mathematician who came up with imaginary numbers. Imaginary numbers are just a way to help us explain things the same way negative numbers help us explain things. Okay? The most basic imaginary number is I, and I is equal to the square root of negative 1. If I is equal to the square root of negative 1, then I squared, when you square root, it goes away, right? So I squared is equal to negative 1. I to the third, we're going to go through this process, is made up of I times I squared. So I to the third is really negative. Negative square root of negative 1. Finally, I to the fourth is I squared times I squared, so I to the fourth is equal to positive 1. Alright, we'll work some more on those when we come to class. Alright, So, complex numbers. Complex numbers are numbers that are made up of a real and imaginary part, and they're usually written in the form a plus bi, where a is the real part and bi is the imaginary part. So, we can do add, subtract, and multiply with complex numbers. When adding and subtracting complex numbers, add or subtract, depending on what the problem says, the real number part, and then add or subtract the imaginary number part. Alright, so we're going to try this. We have 3 plus 4i and 6 minus 2i. So we're going to put the real parts together and imaginary parts together. So the real parts are the 3 and the 6, so 3 plus 6 gives me 9. 4i and negative 2i give me positive 2i, 4 minus 2. Okay, you just have to remember to leave the I there. Subtraction works the same way. Real parts with real parts, imaginary parts with imaginary parts. Remember, though, that there's a subtraction sign, so you have to subtract both times you do this. Okay, so I'm going to do negative 3 and negative 6 together, but remember there's a subtraction sign there. So negative 3 minus negative 6. Then I'm going to do the imaginary parts the same way. Negative 5i minus positive 3i. That ends up giving me negative 9 minus 8i. Okay? If you're confused on that part, it's just the positive and the negative stuff. We'll have to work on that too. Alright, and the last one, I can get my slide together, there we go, is multiplication. So how would you multiply this? So you're going to FOIL the same way you would FOIL if it had X's there instead of I's. Okay, sorry, I had to pause it, so I'm going to start back over at this slide. So multiplication, do you remember how to multiply x plus 3 times 2x minus 4? It's that FOIL method, or some of you may have used the box method. It's the same way when you multiply complex numbers. So if you have, 3 plus 2i times 5 plus 4i. So you're going to take the 3 and multiply it by both the 5 and the 4i. So 3 times 5 gives me 15. 3 times 4i is 12i. Now I have to do the 2i. 2i times 5 is 10i. 2i times 4i is 8i squared. Alright, now I need to simplify that. And the way I do that, I'm going to start with remembering that I squared is equal to negative 1. So this last term, 8i squared, is really 8 times negative 1, which is really negative 8. So therefore, I can put the 15 and the negative 8 can go together, and the 12i and the 10i can go together. So that ends up giving me 7 plus 22i. Alright, we're going to practice some more when we get back to class. Sorry this was so skippy, I had to pause it a couple times. But I will see you next time.